Theorem 10.1. Prove that equal chords subtend equal angles at the center. So here you're given two equal chords. One is CD and AB. We have to show they subtend equal angles at the center. So we'll write given circle with center O and two equal chords AB, CD are two equal chords. Now we need to show they subtend equal angles at the center. Now what is the meaning of this? Now we have AB is a chord. What is the angle it subtends at the center? So from A you join up to O, and from B you join up to O. This is the angle subtended by AB. So angle subtended by AB is angle AOB. Similarly, we have to find out the angle subtended by CD. So here is CD. To find the angle subtended by CD, you have to join OC and OD. This is the angle subtended by CD. So we have to show this angle is equal to COD. So this is to prove. We need to prove this. So here we take up two triangles. We take up AOB, one triangle, and the other triangle is OCD. We need to prove these two triangles are congruent. So for the proof, in triangle AOB and triangle OCD, let's prove that they are congruent. We know AO equal to OB, OC equal to OD. All these are equal because the radii of the same circle. So we write OA equal to OC and OB equal to OD. Reason, radius of the same circle. It is given to us that the chords are equal. If the chords are equal, I can say AB equal to CD. So AB equal to CD is given. The chords are given, equal. Therefore, triangle OAB congruent to triangle OCD by SSS test. And if they are equal by CPCT, I can say these two angles are equal. So I'll say angle AOB equal to angle COD by CPCT. We have proved. So let me draw this again. That means if I have a circle, in that circle there is a center, and if chords are equal, any two chords, suppose I have one chord here and this two, if the chords are equal, then the angles at the center are also equal. This is the angle subtended here at the center will be to this angle subtended here at the center. So if chords are equal, angles are also equal. If the angles subtended by the chords of a circle at the center are equal, then the chords are equal. Now in this, again we have two chords, that is chord AB and CD. But the chords are not given equal. What is given equal is the angle subtended at the center. So here this is the angle subtended by AB at the center, and by CD at the center, this is the angle subtended by CD at the center. So if they are saying if the angles are equal, then we can say the chords also are equal. So given to us that angles are equal. So given a circle with say center O such that angle AOB equal to angle COD, we need to prove that the chords are equal. That chord AB equal to chord CD. So for the proof, we again consider the same triangles. We'll consider triangle AOB, here this triangle, and on the other side we'll consider triangle OCD. So in triangle AOB and triangle COD, we know these are equal. AO equal to OB equal to OC equal to OD because they are radii of the same circle. So OA equal to OC, and then we write OB equal to OD, reason radii of same circle. And these angles are given to us equal. Angle AOB equal to angle COD have been given equal. So we write angle AOB equal to angle COD equal, and that is given. Here they've given to you angles subtended by the chords are equal. That is given. So the triangles are congruent to triangle COD by SAS test. If the triangles are congruent, I can say AB equal to CD by CPCT, and we have proved. So here, if the angles are equal, we can say the chords are also equal. So here we have a circle, we have one chord here, and we have another chord, and these chords subtend equal angles at the center. Here is the center. The green chord subtends this angle at the center, and this yellow chord subtends this angle at the center. Now if the angles are equal, if this angle are equal, we can say the chords are also equal. It's vice versa. If chords are equal, angles are equal. If angles are equal, chords also are equal. Recall two circles are congruent if they have the same radii. Prove that equal chords of congruent circles subtend equal angles at the center. So here we are given two circles that are congruent. What do you mean by congruent circles? Circles that have got the same radii. So let's draw two congruent circles. Means two circles with same radii. So here two congruent circles, one with center, say this is O and this is O dash. So we'll say given two circles, say circle C with center O, radius R, and we have another circle C dash with radius O dash and radius R, because they are congruent circles. Two circles here, we better write two congruent circles. Hence the radii are the same. And prove that equal chords, we need to draw two equal chords. So we draw one chord here, AB, say we call it AB, and another chord here, PQ. So two congruent circles with chords, with congruent chords, or equal chords. Congruent, the correct word to use would be equal chords. PQ and AB respectively. Now we need to prove that the angles are equal. So we need to prove angle subtended by AB will be this angle. So we need to prove angle AOB equal to, here we angle POQ. So let's get on to the proof. We'll take up the two triangles. in triangle POQ and triangle AOB. Here we have OP equal to OQ, and all these are equal because they're radii of two congruent circles. So you can write OP equal to OA and also OQ equal to OB. Reason? Radii of congruent circles. Congruent circles have got equal radii. And then we'll write AB or PQ equal to AB. This PQ is equal to AB because it is given to us equal chords. They are equal chords. So the triangles now are congruent. The two triangles, that is OPQ, will be congruent to triangle OAB by SSS test. Therefore, angle POQ, here this angle POQ will be equal to here this angle AO-B by CPCT. So we have proved. All along here I needed to write this is O-A, O-B. Here also is O-B. So if two chords of congruent triangles are equal, the angles subtended also are equal. Just to summarize this, the first they were given congruent chords were given to us. Congruent circles. What are congruent circles? Two circles with equal radius. So two circles with equal radius. Then it was given equal chords were given. So you draw your equal chords. One chord here, say AB, and another chord here, equal, PQ. They're equal. Now we have to prove that they subtend equal angles at the center. So we have two centers here, two different centers at two different chords, O and O dash. Now we need to prove this is one angle subtended by PQ, this is the angle subtended by AB. We have to show that these angles are equal. So all you do is OP equal to OQ, congruent chords, OQ equal to O, congruent chords, and here you have, so by SSS test the triangles are congruent, and if the triangles are congruent you can say the angles also are equal. So here equal chord, this was given to you. You had to prove that angles are equal, and to prove the angles are equal you took the triangles, you took triangle POQ, you proved they are congruent to AO-B by SSS test. So angle POQ equal to angle AO-B by CPCT. Prove that if chords of congruent circles subtend equal angles at their centers, then the chords are equal. To start with, we need two congruent circles. So what are congruent circles? Circles having equal radius. So here we have two circles. Their centers is O and O dash, but they are congruent, so they've got equal radius. So given two congruent circles, one circle is C with center O, radius R, and the other one is C dash with center O dash, radius R, because they are congruent. The next part they say we have to prove that subtend equal angles at the centers if the chords subtend equal angles. So we need to have two chords. Say I'll put one chord here, AB, and another chord, say PQ, and these chords subtend equal angles. So here is the angle subtended by AB, and this is the angle subtended by PQ. So we have to write here AB and PQ subtend equal angles at the center, at their respective centers, which means angle AOB is equal to angle PO-Q. Now we need to prove that the chords are equal. So to prove chords are equal, means we need to prove AB equal to PQ. So for the proof, we take two triangles, triangle AOB and triangle PO-Q, and we show that they're equal. Now we know OA equal to OB equal to O-P-O-Q because they are radii of congruent circles. So we have OA equal to O-P and OB equal to O-Q. Radii of congruent circles. So these radii here, this equal to here, equal to this, and equal to this. And the angles also are equal. This is given to us. These two angles are given equal. So we have angle AOB equal to angle PO-Q, and that is given. Therefore, triangle AOB congruent to triangle PO-Q by SAS test. So if the triangles are congruent, I can say AB equal to PQ by CPCT. So I had proved that the chords are equal. So here I had two congruent circles, and in these two congruent circles there were two chords. Say there were two chords here. I don't know if they were equal, but we know one thing is there was a center, and these chords subtended equal angles at the center. So this angle subtended by the yellow chord was equal to this angle subtended by the green chord. Both these angles were equal. We have to prove that the chords were equal. This was a question, to prove these two chords are equal. But since these were congruent triangles, congruent circles, all these radii were equal. This radii equal to this. That is the definition of congruent circles, equal radii. And then the central angle also was equal, which was given to us. So by SAS test, the triangles were congruent. Here SAS, here SAS, the triangles are congruent. So now I could say that these two chords were equal. This chord equal to this chord, because the triangles were congruent. Triangle congruent, so chords equal by CPCT.